What's crappin'? Stop yapping. Build some shit. I am Cordell Rivers III. Today I wanted to go over how I designed my fuel system. So I have everything in my fuel system laid out right here so you could see. So we'll switch over and I'll go through piece by piece what I'm using and kind of what everything's rated for and why I decided to do all that. Okay, so first of all, the first thing I had to decide was whether I want to use a fuel cell or use the stock fuel tank. And I decided to use the stock fuel tank because I wanted to just kind of build everything in advance and I didn't want a full-on, race build. Plus, doing everything this way made it so when I do pull the car apart, hopefully it won't be down for as long and I can get everything going. But what I essentially did was I bought the left side fuel assembly and the right side fuel assembly that go in the stock E36 tank, and then I just modified them so because each one of these assemblies, even with the fuel pump on them and this one with the fuel level gauge, were only about 60 bucks a piece. So I figured I'd just buy them, have them, modify them, and then when it comes time to do the whole fuel system, I simply pull out my stock one and drop these in and then start from there. So what I ended up doing was building a double dash 10 pickup with stainless steel filter socks. These socks I think are 200 micron or something. They're rated to like 400 gallons per hour, which is only half of what, is twice as much as what we'll be pulling, so that shouldn't be an issue. Plus the entire length of this is probably 10 inches, so the fuel won't actually have to draw up very far. And so we basically are just going to draw out two dash 10s. Pickups are going to draw out and go into the two dash 10 inlets on twin AEM 400 liter per hour ethanol fuel pumps. And the reason I decided to go with these is because they're ethanol rated. They have the bigger dash 10 inlets and they're already set up for dash 6 outlets, and they're a high quality pump which will allow me to use the booster pump, which I'll get into in a second. But also these things are obviously out of tank pumps. They're called inline pumps, and I wanted something that wasn't going to be obnoxiously loud like the Weldon pumps are. So I decided to go with the twin 400 LPH pumps, which should be rated, should give us about 1500 turbo horsepower turbo horsepower on normal fuel. So we'll get back to that in a second, but we'll have twin dash 6s going out as our feed lines going through to Earl's. These are, I believe, 35 micron filters. Goes through those and then into both ends of the fuel rail on the manifold. And then you can see the outlet is actually right there. So we're going to have twin dash 6s going in, a single dash 6 going out into the fuel pressure regulator. This is a single in, single out fuel pressure regulator by Aeromotive. I wanted to run that just because it looks cleaner and I don't need two ins and outs and all that other crap. So we'll just run the gauge on the one side, inlet, outlet. Now the return from the regulator is going to go through the flex fuel sensor for the Haltech and then back into the tank. So this is the other side of the tank, which has the stock fuel returns, and I just plugged those and added a dash 6 fuel return bung. They call it a bung coupler, whatever it is, but this is essentially just a dash 6 fuel cell pickup as well, but I just using it for a return. So we'll have the dash 6 return on the one side of the tank, which is the driver's side for US models, and the twin dash 6 outlets or pickups, or dash 10 pickups on the other side. So here's where we kind of run into some issues. So we're going to run out of fuel pumps. If I run E85, these two pumps are going to max out about at 1,000 horsepower. So you figure if these things would run a turbo car at about 35 pounds of boost, which obviously with a 1-to-1 fuel pressure regulator, you're going to be kicking your your fuel pressure up in pressure at a 1-to-1 ratio as per your manifold pressure. So if you're running a baseline of 43 pounds, let's say 40 pounds for the sake of doing the math quicker, and you're running 30 pounds of boost, you're now going to be running 70 pounds of fuel pressure at your rail. So these things start to lose efficiency at the higher pressures you go. So what I wanted to do was I'm going to run the secondary pump on a Hobb switch anyway. This is a 7 PSI Hobb switch right there. So it can be operated on normally open or normally closed operation depending on what you're doing. Most people operate the Hobb switch on a normally open circuit. So the Hobb switch is open, and then when it hits a desired boost level or manifold pressure level, it'll close, and that's when it crosses the bridge and sends your grounding or voltage. You can even do voltage if you wanted, but we're using it for ground. So the secondary pump will be kicking on at about 7 pounds of boost, because a single pump on E85 is plenty for that engine, that 2JZ, up to 7 pounds of boost. There's not going to be any issue at all. So the secondary pump's going to kick on at about 7 PSI with the Hobb switch connected to a relay, which is also going to kick on the booster pump. So we lose 30% of our volume because we're using ethanol or E85, because we're having to use 30% more fuel. So if we're maxing out at 1500 horsepower with these two pumps on let's say race fuel, you're going to have to take 30% of that, which is about 450 horsepower. You're losing that right off the top because you're using 30% more fuel. So to make the same amount of power on ethanol, you're going to have 30% more draw, basically, or demand on these two pumps. So the Bell's booster pump will actually increase efficiency of a single pump by over 30%. So even though we're not boosting both pumps by 30%, so we wouldn't gain that 450 horsepower back completely, we're down at about 1,000 horsepower. So if we kick the booster pump on just the secondary single pump, then we should gain at least about 50% of that overall 30% loss, which should net us like 175 more horsepower capability of the entire system on ethanol. So we shouldn't be maxing out these pumps, is basically what I'm saying. We should have enough room in there. Plus, I don't want to run the booster pump on both pumps because I don't want to stress the pumps out, and the secondary pump is probably not going to be kicking on and off at all during daily driving situations. So we might as well just run the primary pump on normal voltage, high reliability, everyday use. We shouldn't have an issue with that at all. The secondary pump, when it does kick on, when we're cranking on the thing or doing whatever, it'll kick on with the booster pump, and it'll, increase the efficiency of just that one pump. So if we happen to burn out that one pump, we're not going to have an issue with complete loss of fuel pressure. We should still be able to drive the car on a single pump. These pumps also, just so you know, have a check valve built into them in the initial dash 8 line that comes out, and then it's reduced back down to a dash 6. So that's basically what we have going for the fuel system. We're going to run ID 2000cc injectors, which I haven't gotten yet. And but this fuel system should work. The biggest issue that I think we might run into is the priming on the pumps, because these pumps don't like to draw fuel in, but since we're only coming up so high and the pumps are actually mounted below the bottom of the tank, as soon as the pump gets any type of feed from the top, we should end up with a siphoning effect, which will hopefully feed the pumps pretty well. And the other thing we need to take into account as well, which I'll probably end up doing later, or I may not have an issue with it at all, but venting the tank. So now we're sucking a ridiculous amount of fuel out of the tank. You're going to need to vent the tank so we can add that same volume back into the tank. So even though obviously you have a return, I mean, your return is much less because you're applying a pressure and then you have a pressure drop and a return. So you're going to you want to avoid having a vacuum in the tank. So we may end up taking one of these stock return lines, just cutting it up here so it basically becomes a vent and running that line out somewhere with a check valve on it. So it obviously can't suck in air, or it can suck in air but cannot push out air, so we're not losing vapor as the car sits there. Usually that's just a ball, like a gravity ball. They run them in all the race car fuel cells as well. Like if you roll the car over, there's basically a cylinder that has a ball that sits in it, and then if the car flips over, the ball falls down and it shuts off, just kills the flow. So we'll probably just run something similar to that, but with the ball all the way down all the time. Obviously, if there's any pressure, it can't get out, but if there's a vacuum, it'll pull the ball up and just vent. So that's basically what we're going to be running for the fuel system. I don't think we'll have too many issues. Another thing I want to add, obviously, is a fuel pressure sending unit for the Haltech, because then we can kind of map the fuel pressure as well, so we can keep a better eye on that with the ECU. And also it enables us to add some safety features in there in case we have a fuel pressure drop. We're not completely relying on O2 sensor readings to pull the boost out of the car. So we should notice a lean condition technically, hopefully much sooner, by knowing that the fuel pressure dumped, and we can kick it off right there rather than waiting for a lean condition to show itself in the exhaust, which is what you'd normally have if you were just using a wideband. So hopefully this will all work out. Obviously we still got a ways to go, but that's basically what we have going on for our fuel system. It should work really well. We'll see. We never know. So pretty rad. Build some shit.